Okay, Assalamualaikum and a very good evening to everyone because I'm recording this video at 3:44 p.m. Okay, so this video will be on introduction to probability. Alright, so this is chapter 10. Okay, so this chapter is for foundation in science and IT as well. Okay, so this will be covered on 8th of March up until 12th of March, but I will let you watch this video without any limit. It's up to you. But then we will be having 1 hour class based on your timetable 9 to 10. But for IT and foundation in science on Wednesday, we will be having class together. Okay, online class, right? So this video will be discussion first before we go for Q&A session during our class later on. Okay, so introduction to probability. I believe that everyone already know about this chapter. I believe that all of you have learned about this chapter. What is probability? Okay, so this chapter we will cover about six subtopic. Okay, so 10.1 is we will cover on experiment, outcome, and sample space. What is sample space? Concept and properties of probability, type of events, union and intersection. Intersection, they overlap. Union is set A and set B together, we add on. Independent and dependent events, conditional probability and rule of total probability, and one theorem here, Bayes theorem. Okay. Okay, so this is learning outcome for 10.1 and 10.2. Okay, students should be able to understand the concept of random experiments, outcome, sample space, events, and random selection. Okay, relate events as set and use the basic set operation to define outcome of event. There will be a few formula that will be used in this chapter. Understand and exclusive and exhaustive events, define probability, and understand some basic law of probability. Okay, so what is probability? We'll look through this situation. Suppose there are a blue pen. Okay, you have one blue pen, one black pen, and one gray pen. So total there are 3 pens. Okay, what is the chance of choosing a black pen? Okay, let's say you have 3 pens like this. Okay, you want to choose this black pen. Okay, so this black pen, while choosing it, you have 3 possible outcomes. Okay, so when you want, what is the chances of choosing black pen? There are only one black pen here, so you have only 1/3 out of 3 chances to get black pen. So that's why we have 1/3. Okay, so 1/3. This is a basic one, yeah. Let's say I ask you to find what is the probability of choosing blue pen. So since there are only one blue pen here, so we will only have the chance of 1/3. Okay, 1/3. All right. Okay, so this is the basic term definition of probability. So what is random experiment? It is a process leading to at least 2 possible outcomes. At least 2 possible outcomes. Just now the cases, there are 3 possible outcomes: blue, gray, and black pen. In this case, at least 2. Mesti ada at least 2. Okay, yes or no. And then basic outcome, the possible outcomes of a random experiment. Sample space is the set of all basic outcome. For example, this situation, my sample space is blue, black, and gray. We denote as S, so I will just have blue, gray, and black. So this is my sample space. Okay. For example, okay, if you are going to toss a fair coin maksudnya A fake coin meaning that a coin you have head and tail. You have a fake coin, head and tail lah. Maksudnya ada kepala, ada ekor. That is what we call as a fake coin. Kalau coin which is not fair, non-fair coin is like we are giving you coin that have only H and H, or tail and tail. Okay, let's say this is my coin, so this is my head, this is my head as well, so that is non-fake coin. But if a fake coin, you have head and tail. Okay, the normal one. So this is the random experiment. Basic outcome, you have at least two. In this case, you have two outcome. So my sample space is H and T, where we denote as H is head and T is tail. Okay. Event is a subset of basic outcomes coming from your sample space. Okay. For example, you are rolling a die. Okay. A fair dice. Fair dice. A fair dice giving you a point of 1, 2, 3, 4, 5, 6. So this is your sample space. Event is a subset. Okay, for example, from my sample space, I want to have an event of odd number. So I take out from your sample space, you have 1, 3, 5. Or I want to have an event of even number. So even number, you have to put this curly bracket, yeah, 2, 4, 6. What if I want to have an event of prime number? Let's say I denote as B. So my prime number is 2, 3, 5. Okay, 2, 3, 5 is coming from my sample space, subset lah. Okay, one should be okay. List a sample space when two dice are tossed or a die is tossed twice. Okay, maksudnya they ask you to form a sample space. If you have two dice, when you throw it, it's either you have a common number 1, 1, this one lah, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, or you have the first dice, you have 1, second one, you have 2, or you have 1 and 3, 1 and 4. To make it easy, you make a table. So this is the first dice, this is the second dice. Okay, so this is the pairing, okay, the possible pairing of your two dice when you roll it together. Okay, so all together you have how many sample space? You have 6 times 6 is 36 sample space pairing there. Okay, you have this 36. Okay, let A be an event getting the sum of two numbers is 6. Okay, from here kan, summation of 2 equals to 6. So 1 plus 5 is 6, 2 plus 4 is 6, 3 plus 3 is 6, 4 plus 2, 5 plus 1. So that's why you have this event. Okay, number of event is equals to 5. Okay, let B is an event of getting the sum of two numbers is multiple of 5. Multiple of 5 lah. Summation of these two numbers, 1 plus 4 is 5, 4 plus 1 is 5. Okay, 1, 4 and 4, 1 is different, yeah. So the first point is coming from your first dice. Second point is coming from your first, this is the first dice, this one is the second dice. So that's why we say that 1, 4 and 4, 1 is different. Okay, probability of an event definition. The probability of an event A occurring is denoted by PA. P is probability, A is your event. So PA equals to number of possible outcome in A over number of all possible outcome in S. Okay, so number of A over number of S. Okay, back to this previous example. This one, blue, black and gray pen. So my sample space is, like, let's say I want to have A is picking up blue pen. So my number of A is equals to 1 and number of sample space is equals to 3. So probability of A is equals to 1 over 3. Clear kan? Alright. Okay, P is satisfy the following condition. Probability must be from 0 to 1. If more than 1, that is an impossible event. Okay. The complement of an event is denoted by A bar up there. So complement tu maksudnya outside of your event A. Back to this example just now, your PA where your A is picking up blue pen. So just now probability of A is 1 over 3. So the pen that is not blue one is we denoted as PA bar up here. Complement of A, so 1 minus 1 over 3. So you will have 2 over 3. This is the 2 pen left kan? So the probability is 2 over, the blue one. 2 over 3. Okay. And then you can arrange this as well. PA, if you bring it here, P complement of A plus PA equals to 1. These are another properties. These two properties you have to remember. Okay. Okay, example, 2 dice are tossed together. Find the probability the sum of 2 numbers is 8. Okay, if we are talking about dice, so it is better if you draw that table just now. Okay, daripada table to from the table you can take out dia punya pairing of the 2 dice. Okay, just now 1 2 3 4 5 6 1 2 3 4 5 6. So the summation, so you just put plus lah. Summation must be 8. So 1, there is no summation of 8 here. 2 and 6. So you have 2 6 here. 3 and 5. 3 and 5. And then 4 and 4. 5 and 3. And 6 and 2. Okay. So how many you have? 1 2 3 4 5. So 5. Inilah. This one. And then sample space is all sample space here is 36. 36 is coming from 6 times 6. 6 outcome from the first dice, 6 outcome from the second dice. If let's say I'm saying that 3 dice are tossed together. 3 dice are tossed together. So your number of S is 6 times 6 times 6. Okay. If 4, then 6 times 6 times 6 times 6. 6 power of 4. Okay, understand that? Okay, so this is the probability. The summation of 2 numbers is prime number. Prime number, 1 and 1, yes, is prime number. Summation kan, 1 plus 1 is 2, 2. 1, 2, yes. 1, 3, no. 1, 4, yes. 1, 5, no. Then you have to list down all. Total is a prime number. This one, so 15 over 36, we simplify, we get 5 over 12. Okay, should be clear kan? Okay, next example, 2 fair coins are tossed simultaneously. Okay, find the probability of getting exactly 2H. In other words, PHH. We want to find PHH. Okay, so 2 coins, the trick is, okay, you make it in a tree diagram. Okay, the first coin, the probability, the possible outcome is H and T. Second coin, you continue HT and HT. So this is H and H, this is H and T, this is T and H, this is tail and H. So exactly 2H. Exactly 2H meaning that is this one lah. So the probability for the first coin is 1 over 2. This one also 1 over 2. And then second one is 1 over 2. So probability of exactly having 2H is 1 over 2 times 1 over 2. At least 1H. At least 1H is either 1H only or 2H. So this one lah kan? 2H, 1H and like this one is TT, 1H and this one. Okay, in other words, this is actually 1 minus P, both are T and T. Okay, you can calculate manually this probability, you plus with that one, you plus with that one, or 1 minus getting tail and tail. Okay, this one, getting tail and tail. Okay, understand kan? Okay, we can also write it in Venn diagram. Venn diagram can also be used to solve probability problem. Okay, for this example, there are 100 forms, 6 students, 20 studying biology, 15 chemistry, 8 studying both biology and chemistry. We can illustrate this in a Venn diagram. Okay, you have 100 students, biology 20, chemistry 15, biology and chemistry, this one is the intersection, is 8. Okay, so this is the one that intersect together, biology and chemistry. So biology just now is 20 kan, 20, but then 20 students, 8 of them are studying chemistry as well. So that's why the one who's studying biology itself, biology only, left only 12, because total for biology is 12 plus 8, and then chemistry is 7 plus 8. Okay, 15 kan. So this is the Venn diagram. So inside the biology and chemistry circle, outside is the rest of them. So we just minus lah 100 minus the one inside here. Okay, 73 kan. How they get 73 from here? So 12 plus 8 plus 7. Okay, 12 plus 8 plus 7. So 100 minus 27 is 73. So outside is 73. Okay, so now. Okay, mutually exclusive event. Two events A and B are called mutually exclusive if there is no intersection between the two events. Okay, you have to memorize this. This is the term mutually exclusive. Mutually exclusive. Okay, mutually exclusive is, sorry, when there is no point of when there is no intersection. You see, A and B intersection is empty. So if we write it in the form of Venn diagram, you can see the blue diagram down there. A and B, there is no intersection. Yeah. Okay, so we give you example, rolling a dice again. A getting even number, B getting odd number. So A and B are two events that will not overlap at all. So we can say that event A and event B is mutually exclusive. Okay, what about exhaustive event? A and B are said to be exhaustive event if number of event A, the union of it is the total number of sample space. Okay, you can see from here kan, exhaustive event. Okay, from here, S is the sample space, the number from 1 to 10, and event A is number 1 to 6, and B is number 5 to 10. And then number of A union B equals to number of sample space. So we can say that A and B are exhaustive event. Okay, very easy. This one also, the example that A and B are not exhaustive event. Why? Because number of A union B is not equal to number of space, because you don't have any number 5 here kan, there is no number 5 here. 2 4 6, yes, 2 4 6 1 3. Okay, you left this one. Okay, number of A union B is 5, here is 6, so it's not equal. So we can say that A and B are not exhaustive event. Okay, so this is the conclusion for 10.1. You have to remember this formula, this term. And then just now the formula of PA plus P complement A is equals to 1, or you can arrange it PA 1 minus PA complement of A. Okay, this is the probability. PA equals number of A over number of S. This is the one, and you must know that the probability must be from 0 to 1. Okay, continue. What is this? Okay, continue. 10.3. At the end of this lesson, students should be able to find the probability of an event. Okay, just now sudah belajar kan? Determine probability of union of the two event. Ada lagi formula that we will apply here. Okay, so this is the formula. PA union B equals to PA plus PB minus PA intersect of B. Okay, why is it like this? Because, okay, this is the formula that they consider a probability of two event A and B intercept together. Okay, so PA union B, PA is this, okay, alright, because they want to find PA union B kan. So PA, the one that I highlight in red, and then pointer in color, okay, the green color, and then my green color, okay, my green color is my PB. So if you realize here, PA plus PB, we calculate this part twice, kan? The intersection one. You already calculate from the red one, and then you add one more from the green color. So that's why we minus it one time here. Understand, kan? So this is very useful. You must memorize ini formula, and you have to understand dulu why we have this minus at the back here. Okay, PA union B equals to PA plus PB minus P intersect of A and B. And then this is the De Morgan rule. Okay, PA prime intersect B prime equals to PAUB prime. Okay, when you move this outside, okay, the sign will be changed. When you move this going outside, so inside itu dia punya sign akan change. Okay, that is how you hafal it. Alright. Okay, this is the example. Given A and B are two events where PA equals to 1 over 3, PB is 5 over 9, and PA intersect B is equals to 1 over 6. Find PAUB. Okay, always remember this formula. PA union B equals to PA plus PB minus PA intersect B. Okay, you have all the information. PA, PB, PA intersect. Then you can find this value. Okay, PA union B, and then this one PA prime union B prime. Okay, use De Morgan rule. You take out dia punya tu sign tu, bawa keluar, then union akan jadi intersect. Okay, PA intersect B prime. Okay, so you can apply that properties of the summation of complement and the probability and its complement equals to 1. So you can apply here. So you have PA intersect B prime is equals to 1 minus PA intersect B. Then you can masukkan this value. And then how about this one? PA intersect B. PA intersect B, if you sketch, okay, PA intersect B begini kan? PA intersect B. Where is your A? A is this part. Okay. Where is your B prime? This one kan? How you can find this area? This is equals to PA minus PA intersect B. Very easy. PA minus PA intersect B. You have that A probability. This one lah, 1 over 3 minus that intersect. Easy. Okay. And then this one D. Take out dia punya sign tu, dia punya complement outside. So sign akan berubah jadi union. So dia akan jadi, what will happen to this? So use the formula lah. 1 minus PA union B. PA union B you already have from the part A. So 1 minus lah. Okay, very easy kan? Okay, example number 2. An integer is selected randomly from a set of integer. Find the probability that the integer is an even number of or divisible by 3. Even number or divisible by 3. Okay. Let A an even that even number is chosen. Our number is 1 to 12. Okay, A is even number, B is divisible by 3. Okay, so the probability of PA from here, PA equals to 6 over 12, okay? And then PB equals to 4 over 12. Alright, so from here you can find dia punya intersection juga ni. The intersection is 6 and 12. So 2 over 12 lah. Okay. If you write n here, maksudnya you are finding the punya number. So probability of A intersect B is 2 over 12. Then only you can write like that. 12 is your S. Okay. So P, this one, if you write in the form of mathematical, even number is PA or is U. N is intersection. AUB lah. This one, AUB. And B is P, even number intersect with not divisible by 3. Since we did not divisible by 3 is B, not divisible by 3 will be B prime. Okay. Not an even number, N is not divisible by 3. Meaning that probability of A prime and B prime. Okay. Ni lah. Alright, very easy. Just use the formula. Okay, macam tadi. Senang kan? Okay. Okay, note that sometimes information is also given in the table form. The value of the probability is defined based on that information. Okay, sometimes you are given in the table form as well. Okay, so A, B, C, D. So this one will be intersection. Depends lah. Kalau di sini intersection, but in this case is intersection lah. Okay. Kalau union, then union. Okay, addition. Alright. PA. Okay, this is the example 4. Example 4, a survey is conducted on a group of workers comprising of production operators, administrative office, security guards. The survey is to determine the total working hours in a week. Okay, production, admin, security. Less than 40, 60. Okay, this is the information given. Okay, one of the workers in the survey is randomly selected. Based on the information provided, calculate the probability of workers being a production operator. Production operator, this one lah, 196 divided by total. What is the total here? Add on 196 plus 43 is 270. Mana sudah pen saya? 270. So this one 196 over 270, and then you simplify. Then the workers who work between 50 to 70 hours. This one 50 to 70 hours. So this is the workers 70, so 70 over 270. Okay, 70 over 270, this one. Alright. And then PA, apa soalan dia? Workers being an admin and working greater than 70 hours. Dia admin, okay. Lepas tu dia work greater than 70 hours. This one lah, 8 over 270. Okay. Workers being a security guard working less than 40 hours. He is a security guard, but then working less than 40 hours. So 4 over 270. Okay, very easy. If they give you in the table form. Okay, so sometimes probability also involves combination and permutation. since you already covered combination and permutation before this chapter kan, sudah cover last week. Okay, so you have to know what is combination, what is permutation, what is the difference between these two. Okay, we recall the basic one. Permutation, you have to be careful with the arrangement kan, permutation. Combination it is not about arrangement. Permutation is about arrangement. They care about dia punya arrangement. For example, if I have okay, if I have this three pen, different color kan, black, let's say this one is a gray ataupun I take out this yellow, blue and black. Okay, if in permutation, how many arrangement I can have? So 3 factorial, 3 different kan, 3 factorial. So when I arrange this yellow in the middle, it will become different number of different arrangement in permutation. But in combination, if I put them in this arrangement, yellow, blue, black, and then I change it to blue, yellow, black, it is considered as one. It is considered same. Okay. In combination, this combination I consider as one. In permutation, I have 6 different arrangement. How I get 6? 3 factorial, right? Because I have 3 different. Okay. Okay, 4 letters are chosen randomly from the word computer. Find the probability all 4 letters chosen are consonant. Alright, letter C must be chosen, letters M and P must be chosen simultaneously. Okay, we are choosing from the word computer. We consider consonant and not consonant kan? So COMPUTER. So this is vowel, this is vowel, this is consonant. Okay, the question is 4 letters are chosen. 4 letters must be consonant. The first one, 4 letters must be consonant. Okay, must be consonant. Alright, what is the formula for finding probability? Probability of A equals to number of A over number of S. Okay, in this case, my S is, since I want to choose 4 and there is no repetition here, so my number of sample space will be 5, 6, 7. So 8 choose 4. This is the total. Okay, and then my A, in this case, A must be a consonant. Consonant. Betul ke ejaan itu? Consonant. So consonant, I have only 5 different consonant here. So 5C4. Okay, 5C4 over 8 choose 4. This one lah. 5C4 over 8 choose 4. Then you can have that probability. The letter C must be chosen. Okay, B. C must be chosen. Okay, so PA. Okay, for this part B, my event A is C is chosen, a must. Okay, number of S, number of my event, so number of S is still the same, 8 choose 4. C must be chosen, so maksudnya 1 choose 1 because there is only one C. So that C, I choose that C. 1 choose 1 multiply with, since you already choose 1, so you left only 3 places for that 4 letters chosen kan? Initially we want to choose 4. We fix that number C must be chosen. So the other 3 is coming from the rest of the word, the rest of the letters. So since C is already chosen, so you left only M, P, T, R, O, U, E. So I have 7. choose 3 lah. 7 choose 3. Then I have that probability. And how about C? The letter M must be chosen simultaneously. Okay. M and P must be chosen. Okay, so now my A is M and P, and M and P is a must. Okay, so my PA now become NA over NS. So 8 choose 4. So 2 is compulsory, M and P, so that one must be chosen. So 2 choose 2 times. Since 2 already chosen, M and P, so you left only C, T, R, O, U, E. So how many of them? 6 kan? So 6 choose 2. 2 only 2 because 2 already fixed M and P. Then you get the probability. I think that should be clear. Okay, this one is the solution. Nanti kamu boleh tengok balik. Okay, this one. 3 red marbles. Same thing, permutation and combination also in probability. 3 red marbles, 4 yellow marbles. 3 red, 4 yellow, 2 green are arranged in one row on a table. Arrange, maksudnya this is a more to permutation. Find the probability all the 4 yellow marbles must be next to each other. Find the probability. Okay. The yellow must be next to each other. So probability of A must be number of A over number of S. So first you need to find number of S. Number of S here, how many you have? Red, yellow and green. So berapa ni? 9. 9 factorial over, why I say over? Because you have repeated identical item. So 3 factorial identical for red, multiply with 4 factorial and 2 green, 2 factorial. So this is the number of sample space. Okay, now you have to find A must be next to each other. So you arrange that yellow first. Yellow, 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 yellow. They must be next together, next to each other. So you left only red, red, red and another 2 green. Okay, so ini must be together. So if you are moving them to the back ke sini, okay, you must move them together. So now we consider them as one unit. Okay, one unit. So how many arrangement that you have to arrange is 1, 2, 3, 4, 5, 6. Okay, so it will be 6 factorial divided by 3 red and 2 green. 2 green. Okay, understand? Inside here yellow, you have repeated yellow kan? When you arrange them inside, so it is 4 factorial over 4 factorial, so still 1 kan? Okay, so this is the number of yellow must be next to each other. And then B, yellow must not next to each other. You already find they are all next to each other in the first part. So B is the complement. So 1 minus, what is the answer from the first part A? Must not next to each other. And then the green marble must be in the first and the last position. 3 red, 4 yellow, 2 green. Okay. And then you have to arrange that the green marble must be in the first and the last position. So green mesti di first. 3, 4, 5, 6, 7. And then another one green last. So they will fix at the front and at the end. So it is 1 and 1 lah. 1 times 1 multiply with 1. So in the middle ini, that the one that you have to arrange. So you will have 7 factorial divided by repeated red and repeated yellow. Okay, over, okay, this is number of green green at the front and end of the arrangement. And then this one is the number of sample space, yeah, over number of sample space berapa tuh? 789 factorial over 3 factorial, 4 factorial, 2 factorial. Okay, barulah you divide. What is the answer here? What is the answer here? Alright. Okay, so conclusion for 10.3, you have to memorize this and De Morgan rule as well. Okay, De Morgan rule as well. De Morgan rule tadi ya, yang if you take out dia punya sign tu, dia punya complement tu, then the sign inside change. And another one is PA intersect B is PA intersect B prime is PA minus PA intersect B. Check this one. Okay, I think that's all for the first video. Yes, that's all for the first video. I'll make another video, the second, I think the second and the third one, because I have almost 117 slides for you. Okay, so thank you for your attention. Let's continue with the second video. Okay, all right, thank you.